Okay, in this video, we're going to do 11.6 and 11.7. So both of those sections work with volume measurements. Okay, so we're going to start out doing the volume of prisms and cylinders. So volume is the number of cubic units in a figure. So our postulates are as follows. The volume of a cube postulate. The volume of a cube is the cube of the length of its sides. So what does that mean exactly? Well, let's get a picture of a cube. So over here, I thought I had drawn one, but apparently not. So let me draw one for you, and then we'll talk about why it's the cube of the sides. So remember, to get a cube, you're going to draw a square, and then I find the easiest way to work with this in Notability is to copy that and then paste the image kind of a little behind it, and then connect the dots, okay, to connect the vertices, I should say. So this looks more like a rectangle, but let's just assume it's a square. Okay, so what we're going to say is that if this is side X, and this is side X, and this is all side X, volume is length times width times height, which is each of those sides. So X times X times X, which would equal X cubed, and then the units would also be cubed. So we'll work with this some more, so don't worry about that if that was not totally clear yet. Okay, another postulate is the volume congruence postulate. If two polyhedron are congruent, then they have the same volume. Okay, that makes sense, because if they're congruent, they have the same measurements. If they have the same measurements, they have to have the same volume. Okay, next, the volume addition postulate. The volume of a solid is the sum of the volumes of all its non-overlapping parts. Okay, this is a very helpful postulate because it helps us figure out the volume of irregular shapes, and we'll get to that example in just a little bit. Okay, so let's talk about general volume formula. So when you talk about a general volume formula, the good examples are volume of a prism and volume of a cylinder. So both of the formulas are the same. They are both volume equals the area of the base, that's what this big B means, times the height, which is the distance between the bases. So this big B means the area of the base. So those are the sections that are shaded in this color orange. That's your base, okay? That's your base. Your height is the area that's covered in green. So this is the green, that's the height. Volume is the base, the area of the base, times the height. So the question is, how do you calculate the area of the base? That's where the shapes differ. So here I have volume is base times height. And again, this base is my little orange guy. And my height is the little green guy. Make him lighter. Okay, so the area of the base, it's just a rectangle. So that's going to be what? Base length times width. So that's basically it. Why don't we talk about a little bit of this down here first? So could you draw for me this kind of shape? So we're going to have a vertical line here. We're going to go all the way across as a horizontal line, and then another vertical line down here. Now I'm going to make a little section here, and then I want to have 4 more sections. So I'm going to say this is all about area. Okay, so it's all about area, and it's really all about area of the base. So if my base looks like this, then I could say that my area is just length times width. Okay, so that's what your area is, just length times width. If it's a rectangle, so this is a rectangle. What if my base was instead a triangle? It looks like this. What's the area of a right triangle? Well, area equals little b, so this is little base, times height over 2. Now notice, little b and big B are not the same. That's how I calculate the area of a triangle. Next, what about a trapezoid? Okay, what does a trapezoid look like? Well, it kind of has two parallel bases, and then it has other sides on the right and the left. That area is going to be, if I call this base 1 and this base 2, you're going to average these bases. So that means add them and divide by 2. And then multiply by the height. Now the height is going to be the vertical height, the height that forms a right angle. Okay, this is your height right there. And that is a trapezoid. Lastly, if the area of your base is a circle, then we know that area, because we worked with this before, is pi r squared, and you're going to have pi in your answer. And that is true if it's a circle. Okay, so now that we have this basic understanding of how we're finding areas of various bases, we can go back to the volume of a cylinder. So the volume of a cylinder is still going to be B times H. That's capital B times H. So let's see if we can calculate it. So the volume of this cylinder being B times H, B is pi r squared. So let's say the r is 6. So that's going to be pi times 6 squared times the height. Let's say the height is 3 times 3. So your volume is going to be 36 times 3. So what's that? So I have 36 times 3. That's going to give me 108. So this would have been 108 pi. And let's give ourselves some units just so we can practice. So that would have been inches cubed, because volume is a cubic measurement. All right, so that's the general volume formula, B times H. So now, remember we talked about this volume addition postulate where you can figure out the sum of different parts to get a volume of an irregular shape? Well, here we are with an irregular shape in example 1. So let's look at that closely for just a moment. And can you see how I can divvy this up in parts? So I'm thinking the entire bottom, if I say, let's see. So if I say that this is like this, so right here, this blue piece goes all the way to the back. Okay, and this goes all the way to the back as well. So if I get that area, so the blue area is going to be what? I have 7 wide times 2 deep times 1 high. So that's going to be 14 units cubed. Let's see if we can find some more pieces. What about this top piece right here? This piece I'm marking up in green. What are those dimensions? Well, this is 1, this is 2, and this is 2. So that's going to be 2 times 2 times 1, or 4 units cubed. And then I have one more section right here. Let's change my color. And what is this going to be? So let's see. It's 1 tall, 1 across the back, and 2 here. So it's 2 times 1 times 1, which is going to equal 2 units cubed, and that's going to be 14 plus 4 is 18, 20 units cubed. So that's how you handle irregular shapes. Divvy it up into shapes you can measure the volume of, and then add the volumes together. Okay, so units are going to be important. So let's do these next two examples with an eye towards units. So what do I see? I see I have a right trapezoidal prism. So I know that this is also 6 because it's 6 in the bottom, so it's 6 on top. So that volume is going to be capital B times H. The area of the base of a trapezoid is going to be B1 plus B2 over 2, and then take that times the height. Okay, so let's continue that up here. So B1 could be 14 plus B2 could be the 6 divided by 2 times the height. And what is the height there? Looks like the height is going to be 3 because it's this height right here. So that's going to be 3. So 20, is that true? No, I think the height's going to be 5. So let me restate that. So this height is the distance between the bases. So that height is going to be 5. Okay? So if I have 14 plus 6, that's 20, divided by 2, that's 10, times 5 is, you just think that. Oh, I'm so sorry. Let me go back and restate this one more time. Okay, I want to figure out the base, the area of the base. That involves this height here. So this is times 3. So let me undo this circle. So I was right to begin with. I have this times 3. This gives me capital B. Then I multiply that by the height, which is this height. So that's going to be a 5. So 14 plus 6 is 20, times 3 is 60, divided by 2 is 30. So I'm going to have 30 times 5, which is 150, and it's going to be centimeters cubed. Okay, so think back through that in case I confused you. Okay, last one here, the right cylinder. So I have to still have volume equals capital B times height. And capital B is the area of the base. It's a circle, so it's going to be pi r squared. So that's 81 pi feet squared, and then times the height, which is 6 feet, because remember the height is the distance between the bases. And so when I multiply that out, I get 486 pi, and I have cubic feet. Okay, this we're going to skip this little guy here, and we're going to talk about Cavalieri's principle. And if you have a volume of an oblique, which means slanted cylinder, this is what you do. Volume still equals base times height. The base is based on the circle, so that's going to be pi r squared, and r is 4, so that's 16 pi, and that's going to be centimeters squared. And now you have to go with the height, which is 7 centimeters. Okay, so they have to give you this vertical height. So that area is going to be 112 pi centimeters cubed. And let me make this just plain centimeters. Okay, so that's how that works if your shape is oblique. You can't get this height. It's not going to be this height in here. Okay, it's going to be the height that forms a right angle. Okay, continuing on, we have some extra practice. So this extra practice lets us divvy up this shape. So let's see what we can do with this. We'll play with some colors. So I am thinking I want my first volume. It's going to be this shape right here all the way to the back. Okay, so right here, my height is 1, 2, 3, 4. My width is going to be 1, 2, and my depth is 1, 2, 3. So far my volume equals 4 times 3 times 2. Okay, so that's one piece. Then I'm going to go into another little piece. Let's go for a pink piece. And why not make that this shape back here? And I think I'm just going to make it right like this. Okay, so your pink is going to be, this will be 2. This is 4. Okay, it's 4 this way, 2 that way. And how deep is it? Just 1. So that volume is going to be 4 times 2 times 1. So that's going to be 8. And this one is going to be 24. Okay, we have a couple of more shapes. Let's grab another color. How about if we just do this here, all the way down to the ground? So what's your depth going to be? So I'm going to have, this is going to be 1. The height is going to be 4. So 1 times 4. And this measurement's also 1 times 1. That equals 4. And the last one we'll do in green. And it's just this little guy right here. And he is 1 times 1 times 1, which is 1. If you add those all up, you should get 37 units cubed. And that's how we deal with an irregular shape. Okay, here's another example of the oblique cylinder. So volume still equals base times height. So my base here is going to be based on the circle. So that's going to be pi r squared, which is 81 pi meters squared, times that height that they had to give us of 12 meters. And multiply those two together, you get 972 pi meters cubed. And that is our volume. Okay, so then I'm going to go through this homework, at least part of the homework, so that you have a good handle on calculating volume. So let's do that next. So I give you all kinds of rules up here. You probably want to look at this and read it and look through the examples so that you understand what we're doing. So notice how they've defined the length, the width, and the height for us. So they're doing the length this way, the width is equivalent to depth, and here's your height. So in case you're wondering how you're going to term these different dimensions, that's the best way to do it. So the length is across the front, the width is the depth, and the height is how tall the unit is. So let's try some of these measurements. Find the volume of these right prisms. Okay, so they're not oblique. Use the answer code to reveal the name of a famous Persian mathematician, astronomer, and poet who lived about 1,000 years ago. Okay, so there's a lot of work here. So this is going to be your length, this is going to be your width, and this is going to be your height. So if I say volume equals length times width times height, you can get 360 centimeters cubed. Make sure you can get that. Okay, here, and remember we can always do volume equals B times height, because the B is the length times the width, right? It's this surface right here. It's the area of the bottom. So a lot of times when we do rectangular prisms, we just say length times width times height, but we're really saying capital B times H. So let's do this next one with capital B times H. So volume equals capital B, which is the area of the base. Your base is a triangle, times the height. Okay, so the height I see is 10 meters. The base is the base of a triangle, so it's 1/2 base times height. So what do I have here? I have my base and my height. Here's my triangle right there. So that's going to be this times this. So I have, let me just back this out a little bit. So I have 1/2 6 times 8 times 10. And that's going to give me 240 meters cubed. Next, I have a trapezoid. So looking at that, I have to figure out the base, and this is going to be the base, okay, like this little face. So this is going to be 12 up here, and I have a height. So remember, capital B for a trapezoid is going to be B1, this is B2, and this is height. So that's going to equal my 12 plus my 16 over 2 times my height, which is 6. That's my B. So get that value. When I get that value, what am I getting? So 12 plus 16 is 28 divided by 2 is 14. So I have 14 times 6. And then what is the height of my shape? It's 25. So I'm going to end up getting 210. Let's say 14. Whoops. Okay, so again, you're going to need your calculator for this. 14 times 6 times 25. And that gives me 2100. And I have meters cubed. Okay? The volume of a cube is 9 times 9 times 9. So 9 raised to the third power is 729. And this is centimeters cubed. Okay? Here your base is a triangle. Here is your overall height. So I'm going to say base times height. So my triangle base is going to be 1/2 5 times 12 times the shape height, which is 18. And that's going to give me 540 centimeters cubed. You should try to do this on your own. Okay, look at this shape. It's a rectangular prism. The area of the base, if I call that my base, is going to be base times height for volume, and that's going to be 5 times 7. Okay, and then the height, if I turn this on its base, is going to be 8. So 5 times 7 times 8 is going to give you 280 centimeters cubed. Okay, our last shape, let's see what this is. So I need to kind of play around with this a little bit. So I'm going to put a line here. And then what else will I do? So let me look at that for a second and we'll figure that out. Okay, so this is a little bit tricky. So look at this 10. This 10 tells me that this is a 10. Therefore, the height of this triangle has to be a 4. So if I say that this is my base over here, and here as well, get your B. You have to do it in parts. And then you're going to be times your overall height, which is the 20. So your base is going to be, first I have a rectangle. That rectangle is 10 by 6. So that's 10 by 6. That's easy enough. That's 60. But then you also have a triangle, which is 1/2 base times height. I know the height is 4, and I know the base is 6. So I have to add those together. So that's plus another 12. So and then this whole number, which is 72, gets multiplied by the 20, which is your overall height if you stand this on its base. So if you have 72 times 20, you are getting 1440 and meters cubed. So if you match up these values, with the letters. So here are your values that I just got. And I'm getting the word Omar. And then his last name is Kayam. So see if you can get those matching letters on your own. Okay, so that brings us to 11.7. So I want to just finish with this, and then I'll let you do that homework. Okay, so the volume of pyramids and cones, I have to give you those formulas. They're on your formula sheet for the final review already. So same idea, the base times the height, but because you have a sharp top to these shapes, comes to a point, you're going to divide that by 3. Volume of a cone, same idea. Volume of a cone, base times your height, and the B, remember, B is the area of your base. Okay, it's not just the base, but it's the area of the base. So down here I say, remember, B is the area of the base, and H is the height. Okay, so let's see if we can practice doing a couple of problems along these lines. So you've got some examples. It's a similar technique to what we've done just a little while ago. Volume equals capital B times H over 3. So volume is going to equal, I have a triangle on the bottom, so it's 1/2 base times height, and that's 4 times 6 times the overall height. So that's going to give me a volume of 36 meters cubed. So check that out for yourself. Okay, here's an oblique shape again. We can handle that because we have the height right here. Volume equals the area of the base times the height over 3. Area of that base is going to be 2.2 squared, pi r squared, times the overall height. And so when I put it all together, I get 21 pi, and it's going to be centimeters cubed. Okay, volume of a pyramid. If the height is 144, I think we're going to skip this. So let's just skip this one and go on to this next one. Okay, what do I have here? I have a volume of a pyramid. That's easier to work on. Find the volume of a composite solid. So that means I have a composite. It's made of more than one thing. So let's build the pieces. So look what I have. I have a pyramid on top of a cube. So to get the full volume, I'm going to first get the volume of the cube, which we know is just 6 cubed meters cubed. So what's 6 cubed? That's going to be 216. So that's part of it. That's the bottom. That's all of this down here. Now let's get the volume of the pyramid. So the volume of the pyramid is going to be what? Well, let's see. I have a base that's going to be a square. So it's base times height over 3. Remember, because of the point. Sorry, so your base is going to be the 6 times 6. So let's do that below here. So I have 6 times 6, and then the height is going to be also 6, but I'm going to divide that by 3. So that's going to get me 72, and these are all in meters cubed. And to get the volume of the composite solid, I'm going to add these two together, and I get 288 meters cubed. Okay, keep going. We've got a couple of extra practices here, and then you just have a couple of things to do for homework. Okay, so here's the volume of a solid, 2 last problems. So what do I know? I see that I have hash marks, so this is going to be 14 as well. So this is a square pyramid. So to get the volume here, is going to be the base, the capital B, so the area of the base times the height. And the area of the base is going to be 14 times 14. And the height is 10. So that gets me 1960. And divide this whole thing by 3. We can't forget that because of the point. So 1960 divided by 3 meters cubed. One more problem. This is the oblique cone. So volume equals base, area of base times height divided by 3. Area of the base is based on a circle. So it's going to be pi r squared. So 1.1 squared times pi. And then that's your area of the base times the height is 2.7. And the whole thing's divided by 3. And when I got that, let's see what I'm getting. Oh, you know what? I said I tried to use easier numbers, but we'll go with these. So I have 1.1 squared times the 2.7, and that gives me 3.267 over 3 pi, and I'm in centimeters cubed, and that's good to go. Okay, so that ends this video.